So hello everyone, I'm Jo. I'm a lead developer at Culture Amp. And one of the things I'm passionate about is good quality code. Now I want to start with a slightly unrelated story. During the 1990s in New York City, violent crime rates dropped by 56%. Now this was almost twice as big of a drop as was seen across the rest of the USA. Many people attribute it to the policies that were introduced by this man, Mayor Rudolph Giuliani. He introduced policies of much stricter law enforcement around minor crimes, like subway fare evasion, public drinking, and vandalism. And this was despite the fact that people were protesting that there were far more major crimes that should be being dealt with. So why did he do that? And why do people think that it worked? Now, social scientists Wilson and Kelling introduced in 1982 a theory they titled broken windows, which was after this example in the article that they wrote. Consider a building with a few broken windows. If the windows are not repaired, the tendency is for vandals to break a few more. Eventually, they break into the building. If it's unoccupied, they may become squatters or light fires inside. And they went on. Consider a pavement. Some litter accumulates. Soon more litter accumulates. Eventually, people leave bags of refuse from takeaway restaurants or even break into cars. The theory goes on to state that if we can keep urban environments free of minor crimes like vandalism and fare evasion, we can create an atmosphere of order and lawfulness, and this helps to discourage more serious crimes from occurring. Now, Kelling was later hired by the New York City Transit Authority, and he worked with them to implement measures to test out his theory, and this included things like cleaning all the graffiti off from the subways. In 1985, later on, he was then hired by the New York City Police Commissioner, and he implemented the same strategy across the rest of the city. What they saw was that over the next 10 years, serious crime rates dropped and they continued to fall. Now, the results have come under debate, but what we've also seen is in similar experiments in New Mexico, in Massachusetts, and closer to us in the Netherlands, similar results have happened. When we create an environment that's clean and orderly, we see less violent crime, less serious crime from happening. Now, we can apply this theory to software. Starts with just a small change that seems harmless. Maybe you had a really urgent bug that you needed to get out for that customer who just couldn't live without the fix. And you promised yourself that even as you put that hack in, you'd come back and fix it later on. But you forgot that you also had that project with the deadline last week, and you just ran out of time. You just don't have time to go back and do that other thing anymore. It wasn't a high priority. But what about the next developer who comes and works on your code? Now, it's a fact that as developers, we spend a lot of our time, probably around 70%, just reading the code that's already there in the code base. But do you know what we're doing in the other 30%? We're copying and pasting. So what do you think happens to that hack that you intended to come back and fix? By the time you get the chance, it's probably proliferated across the code base through this technique of copy and paste. And these are the broken windows in our software. These are the cut corners and the hasty decisions that communicate to other people that this is an acceptable style of coding. But why does it really matter? I mean, when you think about criminology and you apply the broken windows theory to that, that's how it was intended to be used. It's pretty clear. If you reduce the rate of minor crimes, we get the benefit of fewer serious crimes. But in software, your hack might not have looked all that pretty, but if it worked, if it did the job, who cares? Now, Ward Cunningham originally coined the term technical debt as a metaphor for the impact of bad code on software development teams. What he said was, when you want to buy something and you don't have enough money, we can take out a loan. We can have that thing sooner, and that's not a bad thing. It just means that we have to pay the money back with interest. And so for development teams, we can cut some corners. We can do things that enable us to get that code out into production more quickly. But if we don't come back afterwards, once we understand the problem better and use what we learned to improve the code that we wrote, well, that's kind of like thinking that you never have to pay back your loan. And you know what happens if you keep doing that? If you do it with your credit card and you overdraft, pretty soon you can't buy anything. And this happens to software teams. When people rush software out the door and never go back and improve it, it ends up with a code base that's so full of hasty decisions and quick hacks that the developers just can't seem to get anything done. Every time you try and add a feature or fix a bug, you find that it breaks something in an unrelated part of the code base. the rate of bugs that are being raised is faster than the rate at which the developers can fix them, and progress just starts to slow to a crawl. Now, we have a term for this as developers for the code that gets in this state. We call it legacy code. Now, the definition of legacy is something that's been handed down to us. It's something that we didn't build ourselves, right? So by referring to legacy code, what we're kind of doing is absolving ourselves of the responsibility of that. It's not my fault code's broken, that was the legacy code, it was a bug in that. It wasn't me. Now, if we consider the cost of making software over its lifetime, between 40 to 80% of that cost goes on maintenance. So hardly any of us here are actually working on software that we built ourselves. And most of us are leaving our own legacy in the code base behind for the next person. And it'll most likely be there way longer than we are. Now, even if we don't admit it, we've probably all contributed to this kind of bad legacy code at some point or another. I know I have. So it's time that all of our teams started taking responsibility for the quality of all the code in our code base. And when I say all of our teams, I don't just mean the developers in our teams. This is something that everybody involved in the software delivery process should care about. The QAs, the BAs, the Scrum Masters, your product owners, everyone who is responsible for getting that software into production. And you may be wondering, well, how is this anything but a developer problem? Maybe you're thinking about refactoring, something that is generally a developer task. The problem is that even if you have a developer on your team who's an absolute whiz at refactoring, knows every technique in the book, if you don't have quality built into every step of your process, they're just fighting a losing battle. So teams need to do two things to enforce quality in their process. First of all, they need to agree on what it means. What does it mean to have really good quality code? And secondly, they need to then build enforcement of that quality into every step along the way. So what is good code? Martin Fowler said, any fool can write code that a computer can understand. Good programmers write code that humans can understand. Good code has two characteristics. First of all, it works. It does what it's supposed to do. And secondly, it's easy to maintain. Bad code sometimes works the way it's supposed to, or maybe you think it does, but when you go and try and change it, it's often very difficult to figure out which bit you have to change and to change it without being in danger of breaking something in another place. So code that's easy to maintain is easy to read, easy to change, and easy to test. And there are plenty of guidelines out there that will help us to write good code, that will tell us what it means to be good code. But realistically, in any team, you're probably going to have different opinions on which ones of those you think are most important. So you need to decide what the definition is, what it means for your specific team. And once you do agree on this, there's plenty of tools available that you can use to enforce those standards, so that what you've agreed doesn't just end up being something that's written on a wiki somewhere and forgotten, but it's actually enforced within your working processes. And this way, if you have broken windows in your code base, the team is going to learn how to fix them. Now, as I mentioned, developers spend a lot of time reading code, and quite often, since it's not code that we wrote, we don't understand the thought process behind it and why it is the way it is. And even when we did write it, quite often we kind of feel like that as well. Now, the first thing that we can do with code to ensure that it's easy to read and follow is that we can make sure it's well organized. If your code base doesn't have a clear structure, over time, what you tend to find is that all the developers on the team put their own ideas into it. So you have a bit of a mishmash of structures between all the different people and what they thought were right. There's a risk of this leading to duplicate code, so you end up with the same functionality implemented in different ways in different places in the code base. And this becomes a broken window because it slows the team down. They have to spend time to understand if they want to build something new, where do they put the code? Or if they need to fix a bug, where do they find the broken pieces? How you actually decide to organize the code really depends on the language and framework that you're using. I like to follow the principle of least surprise. So if your framework has some recommendations for how you should structure it, then the best thing to do is to usually follow those. That means that developers who are new to your team can be familiar with it, and if they can refer to the documentation to learn if they're not. If you've got something like weight, and maybe you've rolled your own project, you're not even using a framework, then it's best to have clear guidelines for developers who join the team so that they know what your thoughts were, how you want to design it, and how you want the code base to grow. Now, what happens when projects grow to a larger size, and particularly a common pattern with MVC projects, is that we get things like fat controllers and large models, because MVC doesn't really do a good job of telling us, as the project grows, where do you put the kind of things that you would put in a library or something. So these are bad, because if you get a very large model or a large controller, the next developer comes along, and he thinks it's okay to just plonk his next bit of unrelated code right alongside your model. Maybe you've got a 600-line class or something. What's another 10 lines going to make a difference of? Before you know it, you end up with 1,000-line long classes, and trying to refactor those and split the functionality out is just a nightmare. You really don't want to be there. Now, another anti-pattern I see is when you group functionality together into kind of services or managers. If you've got functionality that's working together, code that's working together to achieve a function or a feature, it should be grouped together in the code base. And that way, when developers come to edit it, they know where to look. And if you want to split it out later on, it's much easier if it's just all grouped together in one place. Now, keeping a good, consistent code structure is something that really requires a human brain. It's not necessarily something we can have tools for. What we can do is make sure we're having whiteboarding sessions when we kick off stories, kick off sessions with the team, so that everybody is on board with how the thing should be designed, how it should be structured. You can also use pair programming or code reviews throughout the process of actually writing the code to make sure that the structure is being upheld. Now, however you do it, having a good, consistent code structure is important to keep on top of. And once you've taken care of that, you can think about how to monitor the code within it. Who knows a little bit of JavaScript here? Okay, a few people. So see if you can figure out what this is supposed to be doing. This is an example adapted from the documentation for Select2, which is an open source JavaScript component. And this is essentially the same code, but it's written to maximize readability. It still does the same thing, and it is a little bit longer, but it's clearer what each of the variables and methods are supposed to do. Now, having well-named methods and well-laid out code is one of the things that we can do pretty easily to make sure that our code is more readable and maintainable for other people who come along to work on it. Here's another example, and this time this is rock, paper, scissors written in Ruby. It's deliberately written to be as short and succinct as possible. This is a game for developers. This is fun, but it's not really a good technique to use when you're trying to write an application that a whole team has to work on. Anybody else who comes along to work on your code should be able to open your file and easily read and scan the code to figure out what it is and what it's trying to do. If you have to spend time thinking about where are the line endings, what do those single-letter variables mean, it's much easier to miss some of the subtle bugs that can creep into the code. And this is when the overall quality starts to dip. Now, having code guidelines is one way that we can enforce consistent code quality. And we can ensure that the code overall is consistent, easy to read, and also easy to scan for people so that then you're concentrating on understanding the functionality. Now, actually agreeing to code guidelines in a development team is often fraught with tension because who knew developers have pretty strong opinions. And sometimes pretty strong opinions about things that don't matter all that much, like white space, for example. Types of quotes. Now, the important thing here is not necessarily which one you choose, unless you're using a language that is white space dependent, but the team needs to stick with whatever your choice is. And if you think this is nitpicky, if you've ever had to do a code review with a whole bunch of changes that look like this, where it's really just white space, or if you've had to pick through all the commits trying to understand the history of something, and most of them are really just changes to the style of the code, or if you've had developers correct the code to their own preferences because they don't agree with someone else's white space style, well, you understand why these things, if you can agree on them, start to make things much smoother for the team. Now, the good news is that once you have an agreement in the team, you can configure editors and you can use tools that make these things almost an invisible part of the coding process. Most code editors allow you to configure simple things for the code layout so that every time the file is changed, it's enforced. And so that in that way, all the code files in the code base become very consistent and easy to read. Now, coding standards and these tools that enforce them also help us to make the code easy to change. Now, we are probably mostly following Agile processes here, and if we're in this conference, we probably know that changing in software requirements is a fact of life. It's always going to happen, right? We have agile processes that make it easy for our users to change requirements. But when it's hard to change the code, that's a broken window. New features are going to take a lot longer to introduce. Product managers start to complain about how long things take to go live, and developers start to take shortcuts, and before we know it, we're in just developer hell where nothing's happening, and we're constantly just fixing bugs. Now, if the code is already easy to read and understand, that's a really great first step to it being easy to change. Anytime we want to make a change, we should be aiming to change as little as possible of the code base, and that way the risk of causing bugs or causing some problem in an unrelated part is far lower. And we can follow a few guidelines to help ensure that the code is easy to change. First of all, we should pay attention to cohesion and coupling within the code base. And the code should aim to be highly cohesive and loosely coupled. Now, cohesion refers to how the parts of a module are related together. So whether they're working together to achieve a single, well-defined function. And when the code is grouped into highly cohesive modules, it's much easier for developers to work with them. You know where to go if you need to change some of the code. It's not scattered throughout the code base. You don't have to go looking for it. There are some things that you can actually observe in the code that are indicative of code that is likely to have low cohesion. So first of all, classes that contain many methods that don't use instance variables, or if they don't refer to other methods in the class. This is often true of utility classes. This is a prime example of areas that don't have very high cohesion. If a class has multiple responsibilities, the single responsibility principle tells us that each class and each method should only do one thing. And so if it's doing more than one, the chances are it's probably not very cohesive. And if we have methods in the class that take a large number of parameters, they're probably doing things that are linked to other areas of the code base as opposed to the class that they're in. When it comes to coupling, similarly, there are things that indicate high coupling. And coupling is when the code is linked to other areas in the code base. So ideally, what we want to have is a module that really has a fairly small interface and isn't strongly linked to lots of other places. Because if we change that module, then we have to change lots of other places in the code. So classes that have a large public interface can be used in lots of different ways. If we then want to change that interface, it's going to affect a lot of parts of the code, so it's highly coupled. And if we have class initializers with a lot of parameters, this is also an indicator that they're probably working with too many different objects. And when we come to change them, they're going to have too many links to other parts. The third thing that we want to watch out for is duplication. There's the literal kind of duplication where you've got the same lines of code appearing in more than one place. But there's also the more subtle kind of duplication where you implement business logic in multiple places. This is the more dangerous one, because when you want to go and change that business logic, it can be quite difficult to know all the places that it exists. The third thing to watch out for is cyclomatic complexity. Now, this is a measure of the number of branches through your code, and it can be measured on different levels, so a file, a method, a class, even the entire code base. It's not very easy to actually count it manually. I'd run out of fingers and toes when I've tried. But it's easy to see when you've got high cyclomatic complexity. And these are some of the things that we can watch out for. So if-else statements, loops, case statements, and long methods. Now, these become particularly evil when they're nested one inside the other. So, for example, if you have code that has a very high cyclomatic complexity, if you have a key piece of logic nested in a loop inside a case statement somewhere, it's much harder when you want to refactor that to pull it out, to write tests around it, and to try and change it. Now, all of these things represent code smells: low cohesion, high coupling, duplication, cyclomatic complexity. If other developers see code that has a lot of these smells in the code base, then the tendency is that they can copy the similar style or perhaps even copy and paste the code itself. And these things start to become more common. These are the kind of broken windows that we want to get away from. But on the other hand, if you have a process that can catch these things at the point when they're introduced and stop them from even getting into the code base in the first place, then you can start to really improve the quality as you go along. Now, we can use tools to catch these. And one of the big advantages of using static code analysis tools, as they're called, is that if you were to have a person on your team who would go through and review your code every time and tell you where you've done all these things, it gets really bloody annoying. This is really not good for team working relationships. Now, code analysis tools you can swear at all you like, and you will when you start using them. But they still continue to nitpick your code and find all of the little tiny problems in it every time. The tools are usually pretty opinionated. They have a very wide set of rules, but most of them are very configurable. And so once you've decided as a team the specific things that you care about and you want to enforce, you can just configure the tool so that it will tell you every time. And once you have done that and you've agreed on what's important, it becomes much harder to ignore. You can't argue with the code analysis tool. It's picked up this pattern in your code, and it's objective. The best way to work with them as well is to run them on every single commit. And I'll show you some that our team uses later on. This way you get new problems being identified as soon as they're introduced. And if you really want to pay attention to keeping the quality up, you can fail the build every time it finds one of those problems. Now, this can be pretty difficult for teams to get used to. It's quite rigorous having that level of enforcement, but it really does help them to learn good habits and to improve the quality of the code across the code base. So let's talk about what makes code easy to test. Now, the best, easiest code of all to test already has a set of robust tests, and they run fast and they're green before anybody even starts to make changes to them. The nirvana for well-tested code is pretty much what Paul described this morning if you saw his presentation. Every developer, before they even commit, runs the entire suite of tests on their machine. The reality is for many code bases that they get very large, and it's actually very, very difficult to keep your build time under 10 minutes, even if you're running it on parallel machines. Nobody's going to sit and watch tests run for 10 minutes at a time, several times a day. That's just really, really boring. So it's very important that we try and pay attention to build time and to keeping it low. Now, at a very minimum, we should keep it green. We should be using a continuous integration tool that runs the tests in every build, and that failing tests actually do cause the build to fail. A big danger is if you're not paying attention to reb builds. For example, if you have flaky tests, and then developers kind of look at the reb build and think, well, you know, it's probably nothing that I did, it's just a flaky test. If you're not paying attention to that, it's basically broken windows across the entire ground floor of the building. The build should be there to tell you when something that you've just done is wrong and has broken something. If you're starting out in a place where you don't have any tests, or you don't know the status of the tests you've got, or you've got a red build, the first thing you can do is to at least comment out the ones that are failing or flaky and get yourself to a place where you've got a green build, a place that you can then improve from. And once you've got there, the next step is to maintain or improve test coverage. Paul had a recommendation this morning of having a target of around 75% of test coverage. I think the important thing is that we don't necessarily aim for 100%, because that makes us write tests around things that don't necessarily need them. But what we do want to do is make sure that we're maintaining the current level of coverage or improving it with every commit. And there are tools that you can use to measure your current level of test coverage, and you can incorporate them into the build so that every time it runs, it tells you if it's dropped. Now, I want to talk a little bit about the team that I'm on. I've talked a lot about what it means to make good quality code and in general about some of the processes. So we use a bunch of these tools on our engineering team. We have an application which is primarily Ruby on Rails, and it has a fairly sizable bit of JavaScript in the front end. And this is our continuous integration system. It's called BuildKite. We have a Ruby build, and the first step there is that we run a tool called RepoCop. And it consists of a number of different types of cops, and they all check different things in our Ruby code. The style cops, first of all, look for stylistic problems, and they're based on the Ruby style guide. But like I said, it's very easy to configure it so that you can have your own team's style guide that you use. It looks for things like whitespace, variable, method naming, and so on. Then has lint cops, and these look for things that can be possible errors. So things like unreachable code, or leaving in things like debugger and eval, which I have done with the best of intentions a number of times. The metrics cops are some of the most interesting. These ones look at things like the cyclomatic complexity and the overall size of the class, the method length, the number of parameters that you're passing in, and they flag when they go over certain limits. Performance cops are specific to Ruby. They look at Ruby idioms, and they look for where there are examples of things that you could use instead that perform better. And the Rails cops look for common antipatterns in the Rails code. Now, RepoCop allows us to tweak these via a configuration file. And what it lets us do is not only to have one setting for the code base, but we can specify different types of code where we're a little bit more lenient. So tests are one example where we don't have quite as tight of a check, because some of the test code we don't mind so much if there's a little bit more duplication in, for example. And it also allows us to disable a cop for a particular part of the code. So this is one of our capybara helpers where we have a debugger so that we can run it in the middle of our capybara tests when we're working on them. You could also do something like if you had a very long method that you never change and you know that it works, then you can just disable the method length cop for that bit. And it also lets us create a to-do file. And what this is doing is essentially boarding up those broken windows, those parts of the code base that we know aren't great, and we know we want to fix them, and so we just count the number of bad occurrences there are in the code base so that we can make sure it's not getting any worse. And we can just exclude the odd bad file here and there that we're just not ready to fix yet, but we do know that it's not desirable. Now, RepoCop runs as part of the build, which means that if anybody introduces any of these problems, the build fails straight away as soon as you have pushed your commit. So it's pretty much impossible for any worse code than we already have, I should say, to make its way into our master branch. We have a team culture where we do pay attention to a green build, and we can't merge any of our feature branches until the build is green on that branch. Now, the second stage runs ESLint, and this is kind of a grown-up version of JSLint. It's much more configurable and extendable than JSLint used to be. It allows plugins, which is really handy because you can use plugins just for the specific type of code you write with JavaScript. It has a bunch of checks that it uses, so it looks for potential errors, things like unreachable code again, left-in debuggers and those kind of things. It also enforces best practices, so making sure you've got curly braces, triple equals instead of double, fall through for case statements, and avoiding magic numbers, for example. The third group are to do with variables. So in this case, it's trying to avoid us using global variables and shadowing. Global variables are a particular evil of JavaScript, so we want to avoid those. Style errors it looks for are things like white space, how we use white space, how we name variables, and it also enforces maximum length of files and methods and the maximum number of statements per line. And for us, we've also configured it to check that we're using the latest ES6 features because we want to make use of some of the better features as they're available. Now, the front end of our app is a work-in-progress migration. It used to be pretty much jQuery spaghetti, and we're trying to implement a much cleaner, more modularized React-based front end. So the older code is really not up to being tested by ESLint. So what we've done is, again, configured it differently for the newer code versus the older code, and we've turned off many of the more stricter checks. Kind of means that when we open the files for the old code, it hurts our eyes a little bit, but at least we know we're gradually improving the quality of the new stuff. Now, if any of these linters throw an error, the build is going to fail on us, and so it stops us in our tracks, and we have to fix it for both ESLint and RepoCop. And we don't just use them in the build. They can be integrated with the code editors. So my preference is Sublime Text, and Sublime Text allows us to use linters. So we actually have RepoCop and ESLint running in the code editor while I'm writing code, and it's flagging these issues to me. And this is great because not only does it prevent me from, or makes it less likely, because sometimes I ignore it, but it makes it less likely that those things actually get committed and put into the code base. But I'm learning as I go. I'm learning some of the things that make the code better, and I'm learning to avoid them in the future. Now, the next step that we take to enforce quality is in the build, we run all of our tests. We have unit tests for the Ruby, unit tests for the JavaScript, and we also have acceptance tests, and we use Cucumber and Capybara for those. We've had a lot of problems with flaky tests. It's pretty common when you're trying to run your application in a browser and run it end-to-end. So we've really prioritized making sure that we fix them, making sure that we don't have random tests failing in the build that we can blame instead of our commit when something goes wrong. We've also run into issues with ordering of tests, and so we've implemented measures to try and make sure that all of the tests are green and not dependent on each other, no matter which order they run in. The next step that we have is to measure code coverage, as I mentioned before. We do this for the Ruby code. We don't do it for the JavaScript at this point, and we use a gem called SimpleCov to do it. It starts at the start of the test run, it watches the code, and it tests which lines are being executed. And at the end, it tells us the overall percentage of the lines that were executed. And it produces this kind of report. So it stores a file called last run, which calculates the percentage. And when it runs in the build, it compares the coverage that it calculated to whatever is in the last run. So if it's dropped, again, it fails the build. We could just update the file with the lower coverage percent, but that actually involves us deliberately doing something bad, so we don't. And we do have this report, so if you have dropped coverage, you can go and try and figure out where it was why it dropped and where the drop occurred. Now, outside of the build, we also use a tool called CodeClimate. It's not free, unfortunately, but it's something that our team has found to be very useful. It runs a number of code check tools across the code base, and it tells us when new issues come up. So although it doesn't actually stop the build and turn it red, what we do instead is to include it on GitHub on our pull requests. So we are using Git for source control, and we use GitHub to store the code. So every time we are ready to merge a feature branch, we create a pull request. And you can see these badges on them, and it's telling us that whether the build has passed and whether CodeClimate has passed. So we've created a deliberate culture in our team around looking at CodeClimate, whether it's reported any issues, and making sure that we've fixed all the relevant issues before we merge the branch. And we don't just put it in GitHub. We also have it in Trello, and we use Trello rather than Jira to track our, so maybe we're not agile, but sorry, that was a joke from the last presentation. But we're using Trello to track our work, and we have this badge here. You can see it says 1 of 2, which means that one of those 2 checks has failed. So what we're trying to do is make it very, very visible. If you've checked in something that we've decided in our standards that is not the kind of quality code that we want to have in our code base, we're not stopping you necessarily from merging it, but we are going to flag it and make it visible to the entire team. Now, although CodeClimate isn't free, there's some pretty cool static analysis tools that you can get for free. Some of the ones that are available for Ruby are RepoCop, which I showed you a little bit about earlier. There's a tool called Reek, which also looks for a number of common code smells in the Ruby code, and this is one of the ones that CodeClimate uses in its analysis. There's one called Brakeman, which identifies common security errors. There's a tool called Flog, which uses a measure called assignment branch call to identify areas of the code that are overly complex, and it will flag them to you if they're over a specific score that you can configure. Flay looks for areas of structural duplication. So what it's trying to do is look for those kind of subtly duplicated pieces of logic in the code base. And RubyMine is one of the JetBrains family of tools, so IntelliJ, RubyMine, and so on. And it comes with its own kind of static analysis that you can run within the editor. Now, if you're using something like Java, there's plenty of tools available as well. These were some of the ones I used to use when I wrote Java. So checkstyle looks at whether the code is meeting the style of whatever your coding conventions are that you're using for your Java code. Find bugs is looking for some of the subtle bugs that may occur. And IntelliJ, again, has the same kind of static analysis tools that you can run across the Java code. This is an example of the checks in IntelliJ, and you can see that it shows you a list of the problems, and it also highlights in the file that you're looking at on the right-hand side there where exactly those problems are occurring. If you're using .NET, then Visual Studio also has some similar static analysis tools. When I used to write .NET, I think we used FXCop, but apparently that's been merged into Visual Studio now. And ReSharper is the JetBrains plugin for Visual Studio, which has the same code analysis tools that you can see from IntelliJ and RubyMine. Ndepend is a tool that will tell you how coupled the code is and how related different areas of it are to each other. And NCover is a tool that you can use to measure test coverage. Now, I work for Culture Amp, and we consider ourselves to be a company of people geeks, as the t-shirts say. So it's really only appropriate that I spent some time talking about the more people-focused ways that we can bring code quality into our working processes. I think I've emphasized quite a bit in this talk. The first step in improving quality is for the team to agree on what guidelines they want to follow. If you don't start there, you just end up in endless debates about what it means for code to be good for different developers, and everybody has different opinions. Now, once you have guidelines agreed, whether you practice regular pair programming or you have code review as a separate step, there's no doubt that having a second pair of eyes on any changes really helps to make sure your quality is staying consistent and high. Now, if you're using something like GitHub, some kind of source code hosting tool, then they usually allow you to do code reviews. There's other tools that you can use locally as well, where you can just comment on specific lines of code. So when somebody wants to merge a change into the master branch, you can actually go through it line by line and put some comments on there about what you think, whether those changes are right or not. And as I've mentioned before, if you've got pull requests on GitHub, you can include these kind of badges so that when the people come to review them, they can use these to judge whether the code is ready to be merged or not. This second one here is from an open source project called Exorcism. A lot of open source projects use these same or similar badges. They're using Travis CI for their build tool, and also coveralls to measure their test coverage. So they include those on all of their pull requests for reviewers. Now, if you're starting to run code reviews for the first time, there's some things that you're going to want to consider. How many people do you ask to review each change, and who do you ask? Now, this is going to depend on your team and the makeup of your team. One of the things that we found was that it's actually a good way to educate people about the code. So we have a team that's made up of a number of senior developers and some more junior people. And we try and have 2 reviewers on each pull request, on each review. One would be somebody who actually knows the code and can comment on whether the changes are going to work and whether it's good quality. And one is a more junior person, so that they're learning about the code and learning how other people in the team think. How do you respond to feedback on a code review? It's not a one-way conversation. I think using tools like GitHub are quite effective if you just want to point out, well, you could have done it slightly differently. You could have used this method. Perhaps you should rename this method or variable. But if you end up in a place where you kind of think they need to start over or a whole piece of code needs to be redesigned, that is much better taken to an in-person conversation. And quite often what happens, at least when I review code, is you see it and think, oh, we can implement that change, we can extend it, we can do more than just that little change there, we can perhaps refactor this other piece of code. But these larger changes are often much better raised as separate cards or separate pieces of work to do. The code review should be a final step. If that's the process that you're following, it should be the final step. It's like a tick in the box as opposed to an opportunity for things to go back to the start again. It doesn't mean it won't happen, but it's the exception rather than the rule. And the other important thing with code reviews is that they need to be prioritized to move through quickly. Quite often, it's not the developer's favorite thing to do to review somebody else's code. They'd really rather be doing their own work. But if you don't prioritize them, and then they sit there, they get stale, you get a lot of merge conflicts, and things are not getting done. We use a Kanban process, and we really focus on pulling things through from the end, so trying to reduce the amount of work in progress, and trying to get things done, and that keeps the focus on the code reviews. We have an unwritten rule, which is that any code review should be actioned within a day, and that's worked fairly well. Now, another thing that helps to slow code reviews down, or I should say hinders code reviews, is if you've got a very, very large change. If you've just got one line to review, they tend to go through really quickly, but if you've got several thousand lines, people start to feel a bit like the dog here. I won't leave that running. So it doesn't mean that all the stories have to be broken down into tiny chunks necessarily. There are some things that you can do to make larger code reviews easier. One thing is to try and make sure that your commits are neat and atomic and that you're using good commit messages. So this is an example of something that is not great commit messages. I don't know if you can see this one at the bottom here in particular. But if you've got a very large change, it's much easier to go through it commit by commit. So you can help your reviewer by making sure that you are putting things into kind of neat chunks and labeling them well. If you're using Git, then it has an interactive rebase tool, so you can go back and change history at the end of the change. But if you're using Subversion or Mercurial or something else, then you probably won't be able to do that, so you just need to be careful. Now, there's other ways as well to try and keep the code review small. We don't have to break everything into teeny tiny pieces that have user value and make all the stories very, very, very fine chunks. But if you're halfway through a change and you realize that there's some refactoring you need to do to complete the change, you can think about whether you can break that off and do it as a separate piece of work. And the same's true if you've taken on a large refactoring change. If there's things that you can do to just break off and do first, what I often see is that other developers will benefit from those as well, and they get through much more quickly if they're small. We had a really large code review on our team that took 2 weeks. It was a big refactoring, It took 2 weeks for it to get merged, and I don't even know how many merge conflicts there were through that time, but the poor developer really felt the pain of that one. Another thing that you can do if you're working on feature code, and this was something that Paul mentioned this morning as well, you can feature flag things. So you can build a little piece at a time, but you're not actually enabling it for the customers. So it doesn't matter if it's not complete, because they're not yet going to see it. You can still merge it into the master branch. And also, discussing design up front can help to make sure that somebody doesn't end up making a massive change that then has to be edited again. So everybody's on the same page when you first start the change. Now, even with the best processes, the most dedicated team, and even if you've got quality built in every step along the way, at some point, you're going to have to do some refactoring. At some point, some decision that you made will probably come back and bite you. And there are some things that you can do to help make refactoring go more smoothly and be easier. The first thing is that we should be doing it as we go along and keeping the refactorings small. If you can do small refactorings and improvements with every story, with every small piece of work that you're doing, then you're less likely anyway to end up in a place where you've got a massive change to make, which is much harder to justify. We want to fix the cracked windows before they actually get broken. And another thing to remember is that as a team, you have a relationship with your product owner, which is built on trust. When it comes to refactoring, they have to trust you as a developer that when you say, we need to refactor this piece of code, that they can actually believe you that it's necessary. And if you constantly say that there's refactoring to do, quite often we don't see immediate benefits of this, and it's hard for them to understand. Refactoring is a long-term investment. So I think we've all got that massive, ugly piece of code in our code base somewhere that we'd love to rip apart and test the hell out of the damn thing, but we need to leave it alone and make sure that we use our refactoring credits, if you like, on the places where we really do need to do it. And this helps us to build trust with the business owners so that they do approve when we need to spend time doing this stuff. One of the techniques that we've used in a couple of teams I've worked on is to have time allocated for refactoring. So at Lonely Planet, we had an engineering week where every 3 or 4 months, all of the engineering team would spend a week just working on improving the code base and really hammering out those horrible changes that we knew needed to happen. At Culture Amp, we have a developer day, which is once a month. And not everybody does refactoring during that time, but quite often as developers, we pick that day to work on the things we know need fixing up. Now, I've talked an awful lot over the last half hour or so about the importance of dedicating time to quality and continuous improvement so that the teams can keep delivering new features efficiently and quickly. Technical debt, when it's in the code, it hurts teams everywhere. It doesn't just slow progress, but it makes us all miserable. Nobody wants to be consistently fighting against the force of technical debt and bugs. So if we can build quality into our team's processes, it's going to have an impact, not just on the delivery, but also on our team's motivation and happiness. Thank you.